thanks for coming along. So the room's quite full, so I'm very happy because I think this is the fourth summit I'm attending in a row, and on every summit there were Nifi talks. So, as I submitted my talk, I was wondering if it's worth to have another Nifi talk, but obviously yes, so which is good. Seems like the technology is in use. Perfect. So my talk is about how to ingest 60 billion rows per day using Nifi. My name is Uwe Weber. I'm working for Telefónica Germany since more than 6 years now, and I had the pleasure to set up our first big data environment in 2014, and of course also to create all the data ingestion which come along with that. Yes, finally we ended up with using Nifi. We had some other technologies in use like Sqoop, self-written applications to ingest data, but as I mentioned, finally we are using Nifi. Agenda-wise, I will give you a short overview about our company, about telecommunication in general, and a few use cases, and then I will switch over to the technical stuff, how we are using Nifi in our environment, what experience we have made, and some drops we have experienced. So don't panic. This is my only slide with financial statistics of our company of our last quarter. Instead of digging in all those numbers, I would like to tell you a short story about our history. Telefónica Germany was founded in 1995 as a company called FIAC Intercom. The remarkable thing is, as a telco, we had no base station in Germany. So then you can ask, how can that work? Now you have no single base station, how can you get your customers on board? And the answer is national roaming. So one of our today's competitors allowed our customers to use their network. This was the way how FIAC Intercom at that time was collecting its customers. In 2002, the company was renamed to O2. So I think this is the name which most people in Germany know the company. The name O2 still exists, but it's not the company name, but it's the premium brand we have today. In 2008, I guess, or 7, we were acquired by Telefónica, so that's our official name now. And the last big event we had was the merger in Germany with E+. From a business point of view, this is very remarkable. It's a tremendous event, but also for a big data engineer, as I am one now, because at that time, Telefónica and also E+ had a similar number of customers, around 20 million. So now if you double your customer base from one day to the other, okay, that's not one day from the other, but if the customer base doubles, this also has some requirements for your infrastructure, also on the big data side you can imagine. No? The good news was at the point that our colleagues from E+ had already allocated money for their own big data environment. So we grabbed that money and we were able to extend our big data environment. So with luck. No. When looking at the history of telecommunication, especially in Germany, we have to start at 1992. So a quick survey. Anyone here who was already using a mobile device in 1992? You did? Okay.
It was a status symbol.
I think the status symbol existed a long time after that, 82. So I have printed here a picture of one of the first mobile devices at the time. It's a Motorola International, I guess it was called. It had a price of 1,500 euros. And while I was doing my research for this presentation, I thought, wow, what expensive. But actually, it's not that expensive if you compare it to the prices we have today for our mobile devices. So if you have a premium device today, you will pay easily 1,000 euros. And if you go to that new Samsung device, which you can fold, you even have 2,000 euros. But of course, if you compare the capabilities of that device, it's a huge difference. So the original device was able only to do voice communication. Today we have our smartphones, which are basically little computers. Next milestone is an important milestone for me, because this is the time where I bought my first mobile device. It was Siemens SX in 1997. In the way to that time, we already also discovered the SMS technology, and we also developed or created the first data-driven communication method, which was called WAP, or WAP, the Wireless Access Protocol. If you never had heard about that, it was an ASCII-based browser, you can say. And it didn't survive really. So in 2000, we had the first real data-driven protocol, UMTS. So anyone started in 2000 using mobile devices? A few more, okay. Then in 2005 or 7, Android was developed, and the first smartphones came on the market. 2007, anyone? Not that much? Yeah. Okay. Okay. To shorten the story, do we have anyone who is not using a mobile device today? Okay, no one. Great. But what I would like to do to show you is we have several milestones in the history of telecommunication, and as you can see, all of those milestones, at least those I have printed here, are data-related. Of course, there were some other milestones like HD voice communication to have better voice control. But in fact, most innovations in the telecommunications went into data. So this is a statistics for Germany, of course. The number of mobile phone users, or the number of SIM cards we have in Germany since 1992 also, yes. In this graph, we have two remarkable points. The first one is in the year between 1999 and 2000. So basically, this is the customer base, all people using a mobile device in Germany, and the number has doubled from one year to another. As you can imagine, these were gold-digging times for telcos. This is unbelievable. The second remarkable point here is in the year of 2006, 2007, I would say, because at that time, Germany had around 80 million citizens. And here, the number of accounts grow higher, which means there were more mobile phone accounts than citizens in Germany. This is a situation where you can ask, how can that happen? So why do I need more than one phone account? And of course, some of you may have a private account and a business account. And if you go a bit further into the right direction, a very important market today is also machine-to-machine. So we don't only have people using a SIM card. There are also many devices around which are connecting to other servers, talking to each other. And that's why we have so many SIM cards meanwhile. So talking about data again. So what you can see here is the amount of megabytes per customer on a monthly base. So while the number of SIM cards seems to be saturated in some way, the number of data usage which is generated by customers seems to be still increasing. This is a challenging situation for telcos, because the more data which is sent over our net, the better the infrastructure has to be. Well, so it's our responsibility to make sure that the infrastructure is able to handle that amount of data which is generated by our customers. As I said, data becomes more and more important for telcos. And the traditional business, like SMS, decreases. And as you can see here, this is the number of sent SMS in billions per year. So it started in 2012 to decrease significantly. So maybe as you remember, in the past you were paid for SMS. Can't remember the price, 9 cents, don't know. Of course, this is money which we are missing. But sometimes it looks better for us, or we have situations where SMS is still important. So these are numbers from Telefónica Germany in the September and in the April last year. No, in 2013. I'm sorry. So you have two lines. The light blue one or the gray one is what we expect on SMS sent per day. And the blue one, the dark blue one, is what we have really seen. And there are two spikes. Oops. Sorry. And question, what was happening there? No. And the answer is this. So there was a football match. Dortmund won. And the other one is WhatsApp was down. So no one was able to use WhatsApp at that time. So people went back to the good old technology and sending SMS to communicate to each other. We really often see some spikes as we see here in the football match. For example, maybe you remember the Felix Baumgartner. That was that guy in 2014, I think, who was jumping from the stratosphere down to Earth. And in our statistics, we were able to see that event. So we had a spike when he jumped, and we had a spike as he landed. So it's curious what people are doing. Yes, what I would like to say to you is telecommunication nowadays is not that what we have seen years before. So telecommunication was talking to each other. Nowadays, data is in focus. You can see this if you look at our tariffs. Today, you will not be charged for a phone call. You will not be charged for sending an SMS. You will be charged for using data. As I mentioned, this is a high demand for us to create an infrastructure which is able to handle all the data which is created by customers. And also, the responsibility of telcos has changed. It's not just say hello to someone else. There are so many services, meanwhile, which rely on having an infrastructure, mobile infrastructure. For example, entertainment streaming. So being able to connect to the internet is sometimes essential for our life. So 3 months ago, I think we had at home a fixed net outage. So on Friday, and we were expecting that we will not have internet connection during the weekend. So my wife thought, I cannot see The Walking Dead. I thought I cannot see Star Trek. So it sucks. It really sucks. Luckily, the internet came back on Friday again, so we had a nice weekend. Okay, then for machine-to-machine applications, it's also important to have a mobile connection. So you can think of transportation or automotive. Trucks are equipped with SIM cards nowadays. Containers are equipped with SIM cards, sending data back to the company, providing the state of cooling and I don't know, So if this does not work, companies have real problems, of course. No? And even more serious things are depending on mobile connections. So in Spain, there's a company which has equipped the defibrillators with SIM cards. We also have that in Munich in the tube stations. So if a defibrillator was in use, it sends a signal to the hospital. I don't know who is delivering it, informing them that this device has been used and needs to be replaced. It would be a very bad situation if the network is not working and you're taking such a device and it was already in use. No. So that's why it's important. And it becomes even more important if you think on technology like 5G. We will see in future, maybe 2021, if you think about autonomous driving. No. So now what are we doing to ensure that our network is working properly? Well, you have to know I'm not working in IT department or in the network department. I'm working in BI. So this might be a bit strange, because what is BI doing with operations? And that's exactly the point. Our BI department is not only doing the traditional things of BI, creating reports and stuff for management, I don't know, presenting some quarter results. We're also supporting our network operations team with information about their network. No? Because what we have in BI is artificial intelligence and machine learning infrastructure. So this is an example here. These information were collected on BI side, not on NT network side. So, okay, this is a no-brainer. So we were collecting the information of a single base station about how many seconds were used within this base station to do phone calls. Further, we are collecting information about the volume that people are causing by using data usage. And here it's quite easy. So the amount of the duration and the download volume went down to 0. So that's easy. We can provide our NT colleagues to say, hey, there's something wrong. But this is not the idea. The idea is to create an infrastructure to provide our colleagues from NT the information. Listen, in a few days, the base station XY will go down because we have collected these information of that device. And this is typical for have an outage very soon. So this is the holy grail of our business intelligence department supporting our network team. Now, we would like to exchange damaged devices before they can cause an outage like we see here. Now, finally, it's about saving money, of course. Now, so this is the infrastructure here we are using. I think this is nothing surprising. So at the bottom, we have our mobile network. In the middle, we have something which is called Adam. Adam is our big data environment, which is advanced data analytic methods. That's a great name. And as already introduced, we are using Nifi to get all the network data into our big data environment. On the big data environment, we have our machine learning tools running to hopefully get the information that the device will go down soon. And all this information will be brought back to our network operations team. Well, of course, there's some monitoring stuff and quality control if the models we are using are good enough. And finally, all the informations go back to operations. Well, we also have use cases. For example, if customers are opening tickets, let's say, okay, I have a problem, internet is not working at all, or I have a bad connection, transfer rate is very bad, so they are opening tickets. And as you can imagine, there are hundreds, even thousands of tickets a day, and we have to prioritize. And this is also something which is done by our BI department. So all the tickets which are opened at NT side, at network side, we are having algorithms to decide which one of those tickets are the most important. And this decision is made within 30 minutes. Okay, coming to the more technical stuff. What you see here is our Hadoop cluster. As mentioned, we have created it in 2014. It was a more or less small environment with 22 nodes. We constantly increased the size of the cluster because in 2014 we started with exactly one use case, and meanwhile we have dozens of use cases running on that machine. So the demand on hardware increased. Today we have 75 nodes. As you can see, 2,300 cores, 40 terabyte RAM, and 1 petabyte of disk. So this is not the final state. So we already have a few more hardware, so we will extend the cluster this year again. As mentioned, use cases are in the network area. I would say 90% of all of our use cases are related to network analysis, defect management, and network planning, of course, also. We only have a few real-time cases which produce marketing information or management information like, okay, today we have sold that many tariffs in that tariff group. So it's not that important for us. It's not that typical use case for us on our big data environment. The cluster is redundant, of course. So we have to avoid outages. So at least the management nodes are redundant. So which means it's HDFS, Yarn. Then our edge nodes also redundant. Well, on edge nodes you have running your scheduler or your orchestration, and it's worthless if you have a running cluster, but the edge node is not running which start your scripts. So this has also to be redundant. Then we have secured our cluster using Ranger, LDAP, and Kerberos. We're also using Kafka for real-time use cases we don't really have. So it's completely oversized our cluster now, but we expect to have more real-time use cases in future. And as mentioned, the data integration is done by Nifi or HDF to have the Hortonworks convention. Nifi is what we are using since 2016. We started small, of course. We had a single node instance of Nifi and only one single data flow. But the more use cases we had running on our big data environment, the more data sources we had to connect to our big data environment. Of course, the demand on Nifi grew. So in 2017, we already had a 2-node installation. We already also had some small real-time integrations using Splunk. And finally, we end today with a 4-node installation, and we moved to Docker. So may I ask, how many of you are already using Nifi? Okay, so about half the room. Okay, so let me start. So first of all, what are we doing with Nifi? A typical data integration on our side looks like this. So we have an SFTP server, which provides us a CSV file, or in our case, many CSV files, and especially very big CSV files. These files are typically compressed. They may or may not be encrypted. They may contain GDPR-relevant information, which has to be filtered, of course. And we are writing the data, which is going to be ingested in Hive tables. So these are the requirements. And if you look at a Nifi flow, it may look like this. So if you have never seen a Nifi flow, then I have to do some explanations here. So we have all those rectangles, the big rectangles and the smaller rectangles. the big rectangles are so-called processors. They are working with data. Some data comes into a processor. The processor does something, is modifying data, adding attributes, I don't know. And the result is sent to another processor. The result is not directly sent to the processor, but is stored in a queue in between. Queues are those smaller rectangles. We're also not talking about data within Nifi. We are talking about flow files. As soon as data arrives in Nifi, we are not talking about a file or a stream or something like that. We are talking about a flow file. And flow files are sent from one processor to another, passing queues. So now back to the example. As I told, typically we have our source data stored on FTP servers. So the first two processors are responsible to collect the data from the FTP servers. The next step is to decrypt the flow file. After we have decrypted the flow file, we go down to decompress the data. The next processor will check if the file is empty. Here you can think about why are we doing this check here and not earlier. If we have seen that a file is not empty, we will send it to a processor which is called split text. I will talk about that in a minute. And then we have a processor which is called here a my processor. Actually, this is a customized processor. This is a processor which we have programmed on our own using Java. And this guy here is doing the anonymization. I will also give you an example. If the anonymization has been done, the file will be written. In that case, I will write it simply to local file system. No. Usually, we will write it to HDFS or to Hive, but for simplicity, I will write it down here into a local file system. Now, the split text processor. Why would I like to split my CSV files? You have to know Nifi is running in a single JVM. It's Java-based. And all flow files which are processed within a processor are kept in memory. So if you have large files, you will run into out-of-memory situations. Therefore, it might be a good idea to split to split in general the files into smaller chunks to avoid out-of-memory situations. And this is what this guy here is doing. Maybe one step back. Why do we have that skip empty files processor not at the very beginning of the data flow? The answer is, if you have an empty file which is compressed, it's not empty. No. If you compress a file which has a length of 0, it will result in a file of a length of 42 bytes, depending on the algorithm you're using. So that's why we can do that after that decompression step. No. Okay, this was a slide. I wasn't sure if I should include it because it's a bit goofy, talking about documentation and comments. But as I mentioned, I am working now 6 years as a data engineer, and yes, I've seen a lot. So when you're doing data integration, you always need to know who is the guy who is delivering the data and who's the one who is collecting the data, who's consuming the data. And in a long time, this information can be lost. So the question is where to document such information. Or you also have to document information for operations. If you have to reload data, what steps do you need to take to reload data? You have to write it down somewhere. The really good place is write it down directly in Nifi. So every processor has a tab, as you can see at the bottom, comment. Write down what's important. And you can also put some colorful rectangles into the Nifi flow directly, which is a kind of text box. You can just simply write down what's really really important. Now talking about a custom processor. As I said, we are doing anonymization. Let's assume you have an input, which looks like the upper part. Well, this is a sample like a so-called CDR, which is generated in our network. It's a call detail record. It represents a voice session or a data session and contains various information about that session. For example, who did that session. In that case, it's an MS-ISDN, so it's the phone number basically. Then we have a start time, when started your phone call. Then we have an end time, when was it terminated. And then the type of CDR, we have voice CDRs if you have a phone call, and we also have data CDRs when you have an internet session, for example, and then it's divided into the different technologies we have, LTE, UMTS, and so on. If it's a data session, we also have the information how many usage was generated. It's just an example. So now for our purpose, it's not important to have the phone number included. So the goal is we would like to anonymize it, or to, in that case, to obfuscate it, like you can see it here. So we still have the country code and the area code. The actual phone number has been replaced by dashes. If you would like to write your own processor for Nifi, it's actually very simple. You have to create a Java class, which is a child of abstract processor. Abstract processor is part of the Nifi API. Then there's a method in this abstract class, which is called onTrigger, and you have to override this method. So this is actually the method which is doing what you would like to implement in Java. Then you have to define so-called relationships. So sometimes a processor has done its work and is moving the data, or the flow file, I have to say, to the next processor. So this would be the success way, or the success branch. Sometimes thing goes wrong. Then you can move the data or the flow file into another branch, which would be, in that case, the failure relationship. Now jumping into the Java, this is the onTrigger method here. As you can see, it expects two arguments. The most important argument here is the session, because we can extract the flow file, the data, from the processor using that session get method. As soon as we have the flow file in our program code, we can use it to do something. In that case, I'm forwarding that flow file into another method, which is called obfuscate, which is looking like this. Here we have an interesting point, because on the previous slide I was talking about a flow file data, and now the flow file has been converted to a buffered reader. So here we are in pure Java, so you can do what you want. In that case, I'm sorry, I'm not a developer for that crappy code here. So a flow file, as I've mentioned, in our case, is a CSV file. So we can read that flow file or the buffered reader line by line. So I take a line and I replace the first attribute within the line with dashes after country code and area code. Well, this is everything which is operated here in that while loop. If that phone number has been replaced with a dash, it would be sent back to the flow file. Oh, sorry. And transferred, in my case, to the success relation. So if you're going to start using Nifi, I would like to encourage you to write your own processors. Not to do fancy things, but to learn about Nifi. So it's a very good method to learn the way how Nifi behaves. It could be some easy stuff like that, but you will meet some interesting points developing such a processor. Okay. Error handling. It's very usual in operations that things are not working properly. So of course also in Nifi things can go wrong due to different situations. So maybe you try to write a file and you have no permissions to write the file. Or if you're dealing with CSV files, maybe the CSV file contains not the correct format or not the correct data types. And you have to react in some way within your Nifi flow. So I have extended the original flow after the put file processor. So here we are assuming that for some reason, maybe permissions, I'm not able to write my flow file back to disk. So, where is it? The upper part, where we have the queue, which is called failure, and also success. I have cheated here a bit to make it easier for me. As soon as I write down a file to disk, the flow file will also be routed to the processor, which is called update attribute. Now, what is an attribute? An attribute belongs to a flow file. A flow file already has built-in attributes like file size, file name, permissions, which it had as it was read from disk. And you also have the ability to provide customized attributes to that flow file. What we're doing here, as soon as a file arrives in that attribute, update attribute processor, we define a new attribute or property, as it is called here, put HDFS retries. Well, this looks a bit strange. We would like to store how many iterations a flow file has taken while processing to that error handling loop. So if we arrive at that processor we're seeing here at the first time, there is no such attribute. So we have to define it and to make sure that we're not dealing with null values. So if that attribute has not been set, we define it to 0 in that case. No? Each iteration, we're walking through this processor, we're increasing that attribute by 1 as an increment. Next, we have a root on attribute processor, which decides if a certain number of iterations has been reached or not. So here the idea is we will try to write down the flow file to disk 3 times. We have a delay in the between, 5 minutes, 10 minutes, an hour, I don't know. But if we have overwritten that limit, then we will route the file not back to the put file processor, but to that log attribute processor. And that log attribute processor is auto-terminated, which means the flow file will be skipped. Well. Okay, so here I have all the attributes which belongs to a flow file in that case. Okay. Then a few words about monitoring. Oh, I'm running out of time, I see. Nifi has its own monitoring techniques, but you will find that it's not sufficient. So you have no alarming functionality within the processors. You only have a limited history. Usually you have your own monitoring infrastructure anyway, and it would be good to use Nifi within that infrastructure. And what you can do, I will hurry a bit. So you can access all the statistics which are provided by processors by using a REST API. In that case, in the first line, you see how you can access the REST API. This is the URL you need to know. And the function I have here is accessing a processor. A processor is identified by a unique number. Now you can have a look into the UI, what unique number a processor has. And then you can filter out the KPI you are interested in. So if you're accessing the Nifi API, it will return you a JSON document. And by using GQ in that case, I will search for a certain pattern, in that case, how many bytes were written. Okay, so this is the output. We have the ID, and we have the bytes written. And now you can take that information and do whatever you want. In our case, we are using Prometheus. Prometheus for our internal monitoring. And in that case, we're writing that information, how many bytes we have written, into Prometheus to get a nice graph in Grafana. I'm very sorry, I'm running out of time. I have to stop here. If you have any questions, I will be here right now for a couple of minutes, so please come to me. Otherwise, I wish you a nice evening. Thank you very much.